right, let's do this example. So the LCD, first, I'm sorry, find the restricted x values. So again, you take whatever x expressions we have in the denominator and equal them to 0. So x is restricted at 3 and at -4. So keep those numbers in mind. We then need to find the LCD and multiply it by all terms. So the LCD is 4 times x minus 3 times x plus 4. So when I multiply it with the first term, the 4 will cancel, leaving 3 times x minus 3 and x plus 4. Bring down the minus sign. Multiply with the next term, the x minus 3 will cancel, leaving the 4 and x plus 4. Again, we're treating this as an equal sign for now. And with the last term, the x plus 4 cancels, leaving 4x times x minus 3. So I would distribute first, which would give me 3x minus 9. Over here, I would distribute, which would give me -4x minus 16. You treat that minus sign as a negative and apply it to the 4 and make sure it affects both terms in the parentheses. And I'm going to also distribute the 4x to give me a 4x squared and minus 12x. I still need to use the FOIL method because I still need to multiply these two sets of parentheses. So that would give me 3x squared plus 12x minus 9x minus 36. I still have the minus 4x and minus 16. I'm going to combine like terms. I have positive 12x minus 9x minus 4x, which would give me 3 minus 4, so negative 1x or negative x. I have a negative 36 and a negative 16, so that's a negative 52. Everything else stays the same. So bring down the 3x squared, bring down the 4x squared minus 12x. Since I have a squared term, we got to move all things to the same side. So I'm going to subtract 3x squared, I'm going to add 1x, and I'm going to add 52. So that this will become 0. So subtract 3x squared, add 1x, add 52. Again, so this is 0. So this is x squared minus 11x plus 52. And unfortunately, it's quadratic, so that means use the quadratic formula. So x equals opposite b, which would be 11 plus or minus the square root of negative 11 squared minus 4 times a, which is 1, times c, which is 52, divided by 2 times 1. So that's 121 minus 52 times 4 is 208, which would be a negative. So there's no real solutions. let me double check to make sure my math is correct. Give me one moment. So we're good. There are no real solutions. All right, so we'll build our number line. And the only numbers we're going to use are 3 and -4. So we find numbers on small intervals. So less than -4 is -5. Between -4 and 3 is 0. And larger than 3 would be 4. And use those as test points with the original equation or inequality, which says 3 over 4 minus 1 over x minus 3 greater than or equal to, alrighty. So I'm using -5 first for all my x's. So 7/8 and 5. So we're seeing is 7/8 greater than 5. And that's false. Now we're going to replace all x's with 0. So turning all my -5s into 0s. So 13/12 for the first one. And 0 for the second. So 13/12 greater than or equal to 0. That is true. So we're going to highlight that region. And again, we still have to test it one more time. This time with +4. So instead of 0, we're changing it to +4. So -1/4. And 1/2. So -1/4 and 1/2. That's false. So the solutions are -4 less than x less than 3. Notice I didn't put the equal bar for the inequality. The reason I didn't use the equal bar is because -4 and 3 are restrictions. So when we do the domain, we don't put brackets because we don't include those numbers. Those are invisible boundaries. So it's the same thing. Just because the equal bar is there in the problem, if these numbers represent restricted numbers, we still got to treat them as if we don't touch them. So no equal bar. All right, so I would like for you to work on these on your own, and this concludes your lesson for today.